This is question number 6. Isabel is given a recursive definition for a geometric sequence, and you can see here that it tells me that the first term, a sub 1, is 120. So I know that I'm starting out at 120. And then it says, this is the recursive part, right? In order to get the next term, take the term that you're at and multiply it by 1/2. That's how I read this. It says the term after the term you're at, right? Here's the term you're at, the nth term. The term that's one more than that, the term that's just past it, is going to be whatever the nth term is times the number 1/2. So this is geometric, and every single time I'm just going to take half to proceed. So if I'm supposed to write the first 4 terms, there's the first term. The next term would be half of that, and the next term would be half of that, and the fourth term would be half of that. So every single term is 1/2 of the previous term. Now, in order to write the part B, that part A said, this was part A, it said write the first 4 terms of the sequence. Part B says write the explicit equation for this sequence. So again, the explicit equation, I need to know the 0th term. Again, as I move forward, as I progress forward here, I'm multiplying times 1/2, right? Multiplying times 1/2. And if I need to go backwards, I can either divide by 1/2 or I could multiply by 2. So my 0th term is 240. And this is what the explicit sequence looks like, right? The value of any term in the sequence, if you place in n, right, the 5th term, n would be 5. The value of any term in the sequence is going to equal the 0th term, 240, times multiplying by 1/2 a certain number of times. So it depends on how many times you multiply by 1/2. Like if you want to know the first term, you multiply by 1/2 once, right? N is 1. If you want to know the second term, n is 2, and it's going to be 1/2 times 1/2. So you can see it starts at 240 times 1/2 would give me 60. Times 3 would give me, times not the number 3, but times a third factor of 1/2 would give me 30. And then times another, the factor of 1/2, the fourth one, would give me another half, which would be 15. Now, as nice as that looks, right, it's not right if it's not producing the correct values. So I want to come in and just quickly grab my calculator, and I'm just going to do 240 times, and then I'll grab a fraction here. Oops. Yep. 1 divided by 2. And I guess I should use parentheses. Let me see. Yeah. And then I'm just going to raise this to the nth power. So again, when n is 1, you can see perfect, it's 120. That's the first term. If n is the number 2, right, that's 240 times 1/2, perfect, n is 60. If n is the number 3, right, it's just times another half. So every single time I increase n by 1, right, it's telling me the next term in the sequence. In fact, this should be 7.5 when I put a 5 in there. So this is the explicit equation for this sequence. It's a geometric sequence. The generator is 1/2, and the recursive rule is right here, right? The recursive rule tells me the value of the first term and how to get to subsequent terms.